Thank you very much. I'm going to introduce one of the really most important organisations for Antarctic scientists, that's SCAR, or the Scientific Committee for Antarctic Research. One of the most important things that SCAR does is bring together all the scientists that work in Antarctica. So there are about 156 nations now that work in Antarctica, and all the scientists from those nations are encouraged to join SCAR and to come together for the meetings. So you can see here it brings the community together, and those scientists also provide important information to the Antarctic Treaty Meeting, which is the governance of Antarctica. So one of the most important things you can see here, thank you Laura, is the meetings that SCAR has to bring the scientists together. Antarctica is a huge continent. There are many countries that do research in Antarctica. There's the need to share large infrastructure. There's a need to share the results. And so there are many of these big conferences organised by SCAR to bring them together. Next year is a big annual meeting of SCAR Science in Chile, which are all welcome to join, because we'll be talking about some of these new scientific research from Antarctica. Oops, I can't go back. There was a map there that showed that there are about 46 member countries across the world that are part of SCAR, so it has a huge constituency joining it. The SCAR has also just developed its new strategy, Urgent Messages from the South, and there's a new strategic plan. Strange having interviews behind me. Never mind, read the slides. So one of the things that SCAR does, it does provide independent advice to the Antarctic Treaty. So there is a SCAR representative sitting in the Antarctic Treaty Meeting, which is an annual meeting. In the annual meeting, it governs Antarctica, but SCAR has an important voice to ensure that all the decisions are made with a strong scientific background. It's, as I'll show you, it also encourages young people and diversity. An important topic that many of us are talking about in Antarctica today are about decreasing our carbon footprint. We use very large ships, don't we know it? We use stations that use a lot of fuel to heat where our scientists are there. We have aircraft that fly across the large distances in Antarctica, and our carbon footprint is something we must be very careful of. So there's a huge interest now in using autonomous vehicles to collect data instead of flying everywhere. The other important thing is the Antarctic Treaty means that all scientific samples and scientific data is shared amongst all the countries, not just in SCAR, but across the whole world, which is really, really important. There are no restrictions to Antarctic data. So, I think one of the most important products of SCAR is this annual climate statement. So they produce this very good book, which is a summary of Antarctic climate. And it takes its main findings from IPCC, but this is summarised here with the latest up-to-date information about Antarctic climate change. It's very easy to read. There are very good diagrams in here which you can take off the slides. And if you go to the SCAR website, you can download a PDF copy, or you can send for one of these hard copies. So if you're interested in Antarctic climate change, I highly recommend that. And there will be now an update every single year from the Antarctic climate story. SCAR has a proper international structure. There are delegates to SCAR, which are the national representatives. So I'm the UK national representative, delegate to SCAR. There is an executive committee. Members are in this audience that are derived from the members of the delegates. And there is a secretariat that organises SCAR, which is based currently in Cambridge in the UK. So members pay a subscription fee, and that subscription fee, if you pay it, it's really, really critical. It's not a huge one, but what it does do is support a lot of scientists. So there are a lot of young scientists. It really encourages APEX. The young scientists are going to be the future of, certainly, of polar science, to work together. As José said, it's a really important organisation. And the young scientists come together in our big projects. So quite a lot of the money from the membership goes to these really important topics. So these scientific research programs, the SRPs, which last for something like 8 years. So they are long science projects. And we've now got 3 big projects in SCAR. One is looking at the Antarctic climate, so all the climate scientists are getting together. One called INSTANT, as was mentioned, which brings together all the people that are working on the Antarctic ice sheet and to understand both the past history of the ice and the future predictions, as Florence mentioned, and also a big project to look at the Southern Ocean and conservation, ecosystems and conservation. And these projects are multidisciplinary, they are also multinational, and they include many, many people that come together to bring together in collaboration and bring their results together. And there are many, many new outcomes and publications from these very successful programs. Oops. I don't know who can turn the slides back. I don't think I can. Should I do that? Let's see.
Let me see. I was told there is a button here. This one here.
Oh, will it go back?
I think so. No, it's coming back?
No.
No, they told me there would be one.
Okay.
I'll check again.
Don't worry. Okay. Well, oh, there we go. I just want. It's gone back. Oh no. I just wanted to show you this one of people working together. So this is a picture from the INSTANT meeting. So this is the group that look at sea level rise in the future. And it is a jolly meeting as well. So they're obviously demonstrating sea level rise from Antarctica affecting more tropical regions of the world. And if some of the scientists are not actually in the projects themselves, there are also support for the discipline groups. So there's the geoscience, life sciences, and physical discipline groups. And they're important because that's where the seeds of these bigger science research projects come in later on. So these are people who are working in their disciplines, they bring their research to the meetings, and through those networks, they then develop the next big meeting, the next big project. Oops, I'm not going to try it. So, oh, here we are. So, get it? Nope. I think there's a problem. Anyway, the next slide coming on was about the Antarctic portals. Yeah. And this is important as well, particularly in this context of this meeting, because there is a portal in which really key scientific papers about the Antarctic, about Antarctic research, are taken and adapted and turned into policy papers. So they're, you know, strict scientific papers are changed into documents that are available for policymakers. So if you're a policymakers, please do have a look at the SCAR portal to see some of these important policy papers that have been put there. And so SCAR is actually also looking towards the future. It's not just about documenting what's happened in the past, but it's a really innovative group that brings together all the scientists in Antarctica to really ensure that we're being able to understand what's happening to the great ice sheets and the oceans and all the ecosystems in Antarctica and the climate that influences our whole planet. So please, if you're not a member of SCAR, please join. And if you know that your country is, but you don't understand what it does, have a look at the SCAR website, because there's a lot of really important information there about climate and of Antarctica and Antarctic science. Thank you very much.
Thank you very much, Jane. We'll take a few questions afterwards when we have all the speeches given. Gerlis, please, on the Hiroyuki for IASC. Thank you.
So they are checking, but in principle, this button should allow to come back, but it does not work.
Okay.
We'll see. If we have your presentation, it will be really great.
Sounds great.
I'm hoping they're getting the presentation slides up. Anyway, thank you very much for the opportunity to present, and IASC has joined the summit here as a partner, and we're happy to support it. My name is Gullis Hugman. I'm the Executive Secretary of IASC, and I'm giving this presentation jointly with our Vice President, Hiroyuki Nomoto. The International Arctic Science Committee is a non-governmental and international scientific organization which was founded in 1990. It's still not working? Yeah. And has evolved since then as the leading international science organization of the Arctic. And its membership today includes 24 member countries active in Arctic research, and I see representatives of several of our member countries here in the audience today. IASC encourages and facilitates cooperation in all aspects of Arctic research, in all countries engaged in Arctic research, and in all areas of the Arctic region. And if your country is not a member yet, we're welcome to have you join the IASC organization. IASC promotes and supports interdisciplinary research to foster greater scientific understanding of the Arctic and its role in the Earth system. We're an observer to the Arctic Council and an affiliate member of the International Science Council.
Yeah, that's it. Okay, so you can see that right-hand side many science subject. The main scientific working body of IASC is 5 working groups, which foster interdisciplinary science. They are each other connecting and doing science. They encourage and support science-led international programs by offering opportunity for planning and coordination, and by facilitating communication and access to facilities. Next, please. Yeah, I'll keep talking. So, with the help of the IASC working groups and international partners, IASC published since 2020 the annual IASC State of Arctic Science Report in the screen, and also this one. The latest version of which was just released 3 weeks ago during the Arctic Circle Assembly in Reykjavik, Iceland. This report focuses on the current Arctic research priority, major ongoing and upcoming project, new and novel Arctic research, emerging Arctic research issues, current gaps in research, observation and data, and emerging issues concerning international science cooperation. The report identifies priorities, linkage, and gaps in the current works of the International Arctic Research Community, highlighting, among others, that Arctic research must be truly interdisciplinary and indeed convergent in order to meet the both Arctic and global challenges. The Arctic Research Community must improve the effort to respect, uplift, and respond to the priorities, voices, and contribution of indigenous peoples and other Arctic residents. International and interdisciplinary cooperation are critical to studying the Arctic system and should be encouraged and expanded.
I need to go back.
Yeah.
Go back. One more?
One more.
One more?
Yes, thank you very much. Arctic data sharing, discoverability, and access and reuse continue to be difficult challenges. But improvement in this area will be crucial for future success when it comes to the long-term monitoring. And finally, current level of Arctic monitoring and research is insufficient to meet the grand challenges facing the Arctic, despite the hard work and investment of both Arctic and non-Arctic countries.
For some reason, this doesn't want to work for me. Anyway, but what are the priorities for Arctic research in the coming decade? Since almost 30 years, IASC has coordinated every 10 years in cooperation with international partners an international Arctic planning process called International Conference on Arctic Research Planning, ICARP. The first one led up to a conference in 1995, and the current fourth ICARP process is leading up to the ICARP 4 summit in Boulder, Colorado in the US in March 2025. ICARP is a community-wide undertaking that okay. You need a special finger for this one. Okay. ICARP is a community-wide undertaking engaging Arctic researchers, indigenous people, policymakers, residents, and stakeholders from around the world to ensure that the Arctic scientific priorities for the next decade are firmly grounded on their advice and needs. Currently, 26 international Arctic scientific organizations and indigenous organizations are involved within the ICARP 4 process. This important and high-profile Arctic Research Community Initiative plays a critical role in not only identifying the most urgent Arctic scientific priorities and knowledge gaps, but also in outlining a strategy to support key partnerships and other avenues to address these research needs. An integral part of the ICARP 4 process is the inclusion of not only researchers of all career levels, but also indigenous people and Arctic residents in the co-creation and co-production of priorities and science plans to address key questions, as all knowledge systems should inform the ICARP 4 process. This is done in cooperation with our indigenous partner organizations within the process, and starting early 2024, the newly formed IASC Standing Committee on Indigenous Involvement will contribute as well. The ICARP 4 process started in 2022 and results are expected in 2026. We are currently in the community input phase, where anyone within the Arctic research community and those interested and related to Arctic research are encouraged to participate. One very simple way is via a survey that is available on the ICARP 4 website, and where you can let us know what you think are the research priorities in Arctic research in the next decade, but also suggestions on how they should be addressed and implemented. For the next phase, we're currently setting up research priority teams for 7 broad topic areas, and Cryospheric Sciences is integrated in quite a few of them. The role of the Arctic in the global system, observing, reconstructing and predicting future climate dynamics and ecosystem responses, understanding the vulnerability and resilience of Arctic environments and societies, and supporting sustainable development, scientific cooperation and diplomacy, co-production and indigenous-led methodologies, preparing present and future generations through education, outreach, community capacity building and networking, and technology, infrastructure, and logistics and services. These teams will work with the input provided in the community input phase to identify the research priorities and to develop science and implementation plans. They will start their work during the upcoming ASSW 2024, and I want to highlight that their workshops there will be open for anyone to attend, even if you're not on any of the research priority teams, and will present draft results during the ICARP 4 summit in 2025. The results will then be finalized and available in 2026. The ICARP 4 process or outcomes will be the primary tool to develop the Arctic research themes for the 5th International Polar Year in 2032-33. For the IPY, discussions have started among several international Arctic and Antarctic organizations early in 2021. A joint statement on the 5th IPY was published by IASC and SCAR in cooperation with WMO, the International Science Council, UArctic, IASA, APEX, and other partners in December of 2022. Just 3 weeks ago, during the Arctic Circle Assembly in Reykjavik, an initial concept note and timeline has been published by the partners currently involved within the IPY planning group after extensive consultations with all the planning partners. As you can see here in the timeline, the IPY is not envisioned as a decade. It is a concerted push in Arctic and Antarctic research in 2032-33, with some projects already starting a bit earlier and then a legacy component afterwards. Planning has started early to ensure required funding programs and dedicated IPY projects can be set up over the coming years. The IPY concept note is available on the IASC and SCAR website, and we have printed copies here as well with us, so you can pick one up if you're interested. If you want to learn more about IASC, ICARP, and IPY, please check out our website and ask any questions you might have. Thank you.
Thank you very much, Gerlis and Hiroyuki. Sorry for the technical problems. Now we give the floor to Lise Andreassen from Norway, President of the International Association of Cryospheric Sciences. Please.
So it's just to push the green button.
Yeah, if you need to go back, in principle, the red one should work. Just press strongly.
Thank you very much. So I present IACS, the International Association of Cryospheric Sciences. And on my first slide here, I show just 2 examples of the melting cryosphere. Last few years have shown unprecedented melting of at high elevations of the Greenland ice sheet, but also locally ski resorts struggle with shorter season. From ice sheets to snow, this is part of IACS. Okay. Yeah. So IACS, what is it? IACS is part of the International Union of Geodesy and Geophysics, IUGG, and it's one of 8 associations. We also have meteorology, hydrology, geodesy, etc. IACS was established in 2007, but our history goes further back through monitoring, snow commissions, etc. IACS has 6 divisions: snow and avalanches, glaciers, ice sheets, cryosphere, atmosphere and climate, for instance cores, sea ice, lake and river ice, and we also have planetary and other ices of the solar system. Since we're now talking about our planet, one planet, I will focus on non-planetary ice. So IACS covers the cryosphere except for permafrost, which has its own association. So IACS, some of our objectives are to encourage research on cryospheric science through collaboration and cooperation, international collaboration. I have to be good at this. To promote education and public awareness about the cryosphere, and to facilitate standardization of measurements and collection of data on cryospheric systems, as you see the stake measurement done here at the mountain glacier, and maybe I lost that point, and the standardization of our measurements. Okay. And I didn't push anything, but okay. Well, that's the excitement of today's talk. So IACS also, I want to mention that IACS has an action plan to implement IUGG resolution on reducing carbon footprint by research community. We do that, but very active online engagement. We don't meet every year. We physically only every second year at our assemblies, and this works very well. So
this is one way that we have cut our carbon footprint. So we also, in our resolution, key points are meeting locations should be optimized to reduce travel, and we also try to encourage and facilitate more online engagement, use of ground transportation for shorter travels. And then, as I said, between our biannual assemblies, we have our annual bureau meetings hybrid or strictly online. Now I want to show you some of our IX activities. I'm not showing all, but I just want to show some of them. We oversee the Global Terrestrial Network of Glaciers, GTNG, consisting of World Glacier Monitoring Service, Random Glacier Inventory, and the GLIMS, storing glacier outlines of the world. Okay. We also oversee the glacier and permafrost hazards, the GAPAs. This is together with the Association of Permafrost. We have a joint commission of ice-ocean interaction. We have several joint commissions, but I emphasize the ice-ocean interaction, very important for this summit. We also have a very new established body, Status of Mountain Snow Cover, where they really try to also collect changes in snow cover. We have probably very soon can launch a new working group on glacier ice sheet delineation, and this is because you have glaciers around the ice sheets, and sometimes they are double counted or they are not counted, and it's very important when we do the assessment what is going to happen with the ice sheets and the glaciers to have accurate and good understanding of what belongs to the ice sheet, what belongs to the glacier, and have a community standard on that one. So through IX working groups, joint bodies, joint commissions, standing groups, we do glacier change assessments, we get improved and richer data sets, we do model and method intercomparison, we estimate future evaluation of snow, glaciers and ice sheets, and we, through these activities we also make best practices and guidelines. We also want to be involved in the International Year of Glacier Preservation, and are involved in that, and the International Polar Year and Antarctica INSIC, for instance, through our joint commission on ice-ocean interaction. See if it changes. One more, yeah. So just want to mention about hazards. Since IX cover the whole cryosphere, we also cover high mountains and glacier regions. So one of the common glacier hazard is glacier lake outburst floods. This example here just show a glacier dammed lake. You can see how it's emptied if you see the red text there, the glacier dammed lake, and it fills up the reservoir beneath. Luckily now they have a tunnel, so this doesn't have catastrophic floods, but as mentioned already by Isemod, we have severe flooding in Himalaya. A recent one in October in India with several fatalities. And global lake outburst floods threatens millions globally, a recent finding says. We also have ice falls and collapses, like the Glacier Marmolada in Italy last year. So this is a photo of that one. And when glaciers melt, permafrost melts, warms, and is reduced, we get very unstable terrain. So this creates a new landscape with unknown dangers. So I'm not saying that all hazards that we have are related to climate change, but when glaciers and permafrost melt the landscape changes and gets more unstable. I also want to mention the mountain glaciers. So this is just an example that I monitor. I monitor it for over 25 years. Just one example of retreating or almost vanishing in mountain glaciers. So in 1942 it looked like this. In 2019 it looks very different, and it has retreated more than 900 meters, really shrinked. It shrinks almost 1 meter per year in thickness. But at this glacier, as at many other mountain glaciers, we have front variation measurements since 1901 and mass balance measurements since 1962. So, but with the global warming, the result may be like this in 2100, all the ice is gone. Maybe only some small leftovers, but that depends on the rate of change. So I want to mention now that global data archives are important. This is the reference network of World Glacier Monitoring Service. The glacier surveyed for more than 30 years. Helstugubren that I mentioned is one of them. And if you go to the WGMS website, you find the mass balance data, and here you really see the red curves with much stronger mass loss since 2000 for this glacier, as for many other glaciers globally. You can also see the length changes. Front variation record is much longer from the 1900s. And Helstugubren is also part of Global Cryosphere Watch and a reference cryonet station by the World Meteorological Organization. I also want to mention that the outlines that we produce from satellite images from repeated glacier inventories are in the RGI and the GLIMS database, Global Land Ice Measurement from Space. And this data set, not only for Helstugubren, but for all of our glaciers, gives us data sets we can use to assess the current change and also model the future evaluation of glaciers. So it's very important, and these data archives. Skal vi se. Yeah, so IX, as I said, lead the steering committee that periodically evaluate GTNG, World Glacier Monitoring, GLIMS, and SIDC. And one of our worries is that the funding of the service is very scarce. It's often short-term, and for instance, especially for the global outline data archive, it's very limited funding, and it's very fragile. So I think funding the services should be an international duty and not just a national duty that it is now. So why important to act? Every 10th of degree matters. As we heard, the Greenland ice sheet and Antarctica are rapidly melting. And both Greenland and West Antarctica will take decades to adjust to the current climate forcing due to the committed response. And then also our mountain glaciers, and we need to stabilize the cryosphere, or at least do everything we can to do it. And this is why, for instance, initiatives like the Ice-Ocean Joint Commission can really go, and they produced a paper last year just discussing about future research directions. So we need continued research and monitoring, global data archives, inter-comparisons, and international collaboration among disciplines, and we also need to fund the current organizations. I would like to emphasize and stress that a lot of the work we are doing from the working groups, the amounts are very, very tiny. So we are lucky that people are really volunteering, they are engaged and they do it, but it's also a very fragile system. So finally, I want to sum up, if I can change to my last slide. We need to reduce the carbon footprint and emissions. Every 10th of degree matters. So to me, it took 250 kilo CO2 to get here and home, flying from Oslo to Paris. I would wish to take the train, but that is a very long story. And I think since I started being engaged in this as a 17-year-old, and we took the night train to Copenhagen, this is no longer possible. So train systems are worse, at least in Norway, than it was when I was a young student. I want to encourage online engagement, and we all need to act, from individuals like us, scientists, and the politicians. And policy makers please make sustainable easy. And this summer I took my kids, you see them on the photo, to see my precious Helstugubren, one of the vanishing mountain glaciers. Maybe I can show it to my grandchildren too, if I'm still active, if I get one. But for the future, next generations, it will be less and less of Helstugubren and also other mountain glaciers in the world. Thank you for the attention.
Thank you very much, Elise, for this moving conclusion. Intergenerational responsibility. The floor is for Arne Snorrason now for the World Meteorological Organization. Thank you.
Good morning, everyone. And I'd like to thank for the opportunity to address this meeting, which I see as a very important one, especially if we can convey the message to the degree that we get reaction from the policymakers and the decision makers. What I'm delivering here is a message on the cryosphere as a chair of the Global Cryosphere Watch of the WMO. But it's based on the conference we held in Reykjavik last year, the Cryosphere 2022, partnering with many, many organizations and groups, and many of them have already spoken here. So we had about 330 scientists, and I like to say about a third of them were early career scientists. And thanks to the scientific organizations for the support of those young scientists. Extremely important when we go ahead. So now I will try this magic here. This goes too fast. So even as the decay of the mountain glaciers are the most visible sign of the decay of the cryosphere, with a devastating impact for water resources, both locally and downstream, natural disasters and regional economies, all the components of the cryosphere are decaying at an alarming rate. Some of these changes are irreversible on a timescale of millennia. So the impacts of some of these changes is local, national, and regional, and we have seen examples of that already this morning. Some are global, and some have very significant positive feedbacks to accelerate the warming of the atmosphere. This is one of the figures from the IPCC report that was discussed very much at this conference. And this is one of the sort of challenging future we see projected here. We see all the scenarios for the sea level rise, actually all the way into 2300 on the right-hand side scale. And we also see something that is highly unusual in IPCC report, is a low likelihood, high impact storyline, including ice sheet instabilities. And we see the variance in the projections on the right-hand side, and this is really one of the big challenges of the cryospheric community, is to address this, and this was discussed here already in a panel. It requires tremendous effort, international effort, in terms of in situ and remote sensing of critical areas in Antarctica and in Greenland, and of course in the ocean. These are some of the profiles of the development of permafrost taken from Svalbard, but the permafrost thaw and degradation is going to increase into the future, and similarly to the sea level, we do not have very strong quantitative projections into the future. This is also a long-term process which can have a major impact on the atmosphere itself when it starts to melt at a large scale. This is a recent picture about the maximum winter sea ice extent of Antarctica, and this is the lowest extent we have seen since the satellite record started. Still another example, and this is also, of course, a system like the Arctic ice, sea ice, that feeds directly back to the atmosphere and to the climate and the ocean circulation. are huge uncertainties in the mountain cryosphere, and we have had some examples already shown by previous speakers. It's the glacial ice volume and the variation of snow cover and the precipitation at high elevation. And this, of course, impacts water resources not only locally and regionally, but also downstream, and as mentioned before, affects maybe billions of people around the world. Then we have the extent and ice content of the permafrost, and of course, the related instabilities that this will cause both to the cryosphere and the soil. I think this works on its own. I just had to speak fast enough. This is an example of the melting in 2022 in the Alps. And this is data from the Alps since 1960, showing, of course, the degradation of the cryosphere in the past decades. But what is scary about this figure is the very extreme values for the last 2 seasons. And these extremes go far beyond the scenarios that the society has been working with presently. So this is still another example that we don't have nearly enough good scenarios for the key components of the cryosphere. So I like to refer to the Secretary General of the UN, Guterres, who calls for a boost in the power of prediction for everyone and build their capacity to act. This is, of course, one of the initiatives that he has led, which is the Early Warning for All system. But most cryosphere-related natural hazards are projected to change in frequency, magnitude, and seasonality. So we need these prediction capabilities in the short term, and we need the investment in the observational systems, and this is fortunately on its way at a large scale. And then we need similar approach to the scenarios for longer term, investment in observational systems and research to lower the uncertainties. And this calls for a major international initiative, much like the Early Warning for All. Yeah, this is interesting. So we need cooperation at an international level, policy, funding commitments, and tools to bridge the gaps, since no one country or region has the capability needed. Coordination through WMO and partners can be an important part of that, with the global cryosphere situated there in a key role. We can extend well-established practices for weather, ocean, and climate to the cryosphere, both for the in situ and also for the space-based observations. And of course, data access, standardization, prediction, etc., that has already been mentioned. And it's a key is the in situ measurements. In my view, we have a lot of funding for the space-based observations and capabilities, but the in situ measurements lag far behind. And it's essential to create effective investment mechanisms for the long-term sustained monitoring of the cryosphere and enhance the understanding and the meeting of information needs for the local, regional, and global, both in the short and the long term. So with this, I'd like to thank you very much for you to listen. Thank you.
Thank you very much, Arne. Very important voice. We move on now to the statement from local communities. So as you understood, we don't have all representatives from the communities being from the Arctic or from the high mountain regions. But Ole Olsvig from Greenland, Inuits from Greenland, is supposed to be with us. Yes, he's here. Thank you very much, Ole. I guess you have a presentation. Yes. Yes. Okay. Let me just check that it's online. It's online. Thank you.
Well, I can introduce myself shortly. Now I'm living in Nuuk. I'm business and administration undergraduate, and we have a digitalization business in Nuuk, and we've been going for 3 years. But I'm from Nayat, a small village in North Greenland, and the last time I checked the stats, there's 45 people currently living in this. And yeah, when I was a kid, we were around 70 people, and you know there are changes. That had happened in that period. I'll be waiting for.
Sorry, Ole. I'm not sure, but I'm not sure about your presentation. Which name is it? There are two.
Oh, okay. One with the scientific, because I have two.
Scientific findings.
Yeah, scientific findings.
Okay.
Yeah. Sorry, I've been busy with several presentations, so. I'll use the visuals because they will help me and help you to visualize how it is. Yeah, this is the one. So I have called my presentation Sida Suartu. Sida in Greenlandic it is the weather, but we use also the same word for all conscious, like you have the connection with the nature in that way. And Sidaksua, it is the world, and yeah, the rest of the world and the people living in it. So here's the picture of me when I was a kid, and you can see we use animals, and we are living. Sorry, okay, we are living sustainably. And on the map, you can see where I'm coming from, Nayat. And you can see the larger map. You can see a lot of islands around, and there's several names of other villages around. And yeah, the map doesn't show, but there's a lot of icebergs and ice around, and you can see how close we are living nearby the glaciers, so we can see them from the windows. And then we have also ice caps on the mountains. So as I said, there's currently around 35 residents, but in summer we get the opportunity to come home, and way of living, you are fishing and hunting in the village, and most of them are fishermen now and hunters. Education. So you can see the house in the middle, the blue one. This is the school I went to, and it is called Nisipatuortia, and it is my grandpa. And my mother is actually a school teacher now there. So I went there, and my mom was a teacher as well. So education, you have 2 ways of living there. You have to learn languages like Greenlandic and Danish, and you have to already learn to come to other towns and finish your certificates as a kid, and then you can go to high school in bigger towns. And then after you have Seoul University in Greenland, University of Greenland, you can go to, and then you can go to Denmark as well for further education. So small villages, they have adapted well with the changes, and they always have been adapting to the changes in the atmosphere, the weather, and what is happening. But yeah, you may know, like, I'll deepen the presentation for the human stakes in the afternoon, but yeah, we don't have infrastructure in roads, we don't have lights outside, and we don't have shop, actually, in my village. So you have to actually travel to the nearest villages to buy necessities. So it can be really tough. So you really depend on nature on it. And yeah, I wanted to show, make it visual how close we are to the ice sheets. And this is the ice sheet we can see from a window. And I took this from this point, the blue point. It's almost around 1 kilometer's height. And you can see this, you can feel the sense of scale, how huge it is, and you really depend on it. And the ice sheet, like, it creates the ecology around you. Like, you have sea mammals, even some land-bound, like icebergs, and even Arctic hares, they really depend on ice. And in winter, the animals, like land-bound animals' way is to travel through the sea ice. And yeah, I wanted to say, like, in the old days, we used to, like, my grandpa's brother, he was telling me last year, actually, how they used to use marine flora to see, like, how the winter was going to be. Like, they will see if they will have a bad winter or good winter, depending on marine flora and how much there is. So they were really relying on, like, the changes and very adaptive, like, pragmatic way of observing what is going on around you in Silla. But nowadays, like, one of the ways you are adapting is that you use technology. Like, my dad and other hunters and fishermen, they use weather forecasts online. So they have to, like, check several weather forecasts and see the best one that is working currently. And we have indigenous community apps like Silla, where you are sharing where the ice on the satellites, current pictures, where they are located. So in that way, you are adapting how you are going to hunt or how you are going to fish, or even just going to another town or village, because it is, it's not the first time we have lost, even in my village, like, people who just want to, who just want to take the needs in the villages, only shopping. Like, think about it, only shopping, you are taking a lot of risks. But I also wanted to say glacial rock floor. As you can see, you have a bit mud, like floor going through ice sheets. And this summer I read Minik Hosing, and he's a prominent professor in University of Copenhagen. He has researched how you can use glacial rock floor in order to minimize effects of CO2. And he has done research in Denmark and in some parts of Africa. And this might be something you can also look into in a scientific field. But for people living there, like the hunters, they have a lot of knowledge in terms of glacier calving. We see a lot of new islands, like islands, new islands without names because of calving, and you have some areas where glacier calving is more active, and you have ice caps which are melting a lot. Like the point I was showing on the mountain, I've been there 5 times, I think, when I was a kid, and last time maybe 5 years ago. But yeah, you could see the changes so much because ice cap is melting, and all the rivers they were flowing. They're not so huge as they used to be. So land-based animals are really depending on those ice caps. And then you have stability of ice. We really depend on stability of ice in winter. Like, as I said, you have to go to the shopping and you have to sell the fish that you got in other villages. And you have to hunt, and you have to use the ice to fish as well. And it's not the only humans, and it is the same for animals around. Like you have seals, which are, trying to be more near around icebergs. Actually, I was talking with my dad, and he was, recognizing it, or like seeing it, how they are closer to icebergs around, especially in summer, to get some coolness. And glacier calving, and we have a lot of areas. The glacier calves a lot more in North Greenland, and the currents change actually depending on the how much glacier is falling. You have new current streams on the sea, and because of the huge icebergs, they make also effects on the currents as well. So those are what the hunters really know. And I was talking with Willingvar Christensen, and he lives further north from me, like also really isolated, Savissivik. And he was telling me they have to, they always had to take dog sleds through the ice sheet, and they had the old ways of traveling in that way. But nowadays, like, because a lot of ice sheet is melting and collapsed, they have to adapt to it. Like sometimes they take helicopters from that village to Qaanaaq, and they will look around what is the best option for traveling. So they'll find new ways, but new ways are always dangerous. Like you're always like the first one who's testing that ice, or like ice sheet. But it is always adapting the way of life we are living. And I wanted to say yesterday was International Inuit Day, actually. So I want to recognize Inuit, Inupiat, Yupik, and Chukaka around Greenland, Canada, Alaska, and Siberia. And today is the day where, polar nights start in my village. Like today, I think almost soon, the sun will rise a little bit, and then they won't see the sun for 3 months. So they will have polar nights. And when it's completely dark, you have to like really feel the whole nature around you. And it is very, you have to sense it. And they have a lot of knowledge in our own language. Like, I really have to process a lot of things when I'm presenting, like the way that I want to show. And so for the last thing, I wanted to say importance of inclusion of local communities is really important. So I'm really honored to be here and really privileged to be here. I just arrived in the middle of the night, but I really wanted to be here, so I'm jet lagged, but I'm not used to like part of this amount. But yeah, corresponding to some testimonies by observing Silla, the weather. This is the way we do it in Greenland, especially in smaller communities. They have a lot of knowledge they want to share. And actually, in NIAD, in 1966 and 68, there was an anthropologist by name Jean-François Lemule, and he has been there for 2 years, and he was really connected with the local community. And even my dad is named after him in the middle. So they know what is happening around, and they want to share, and they need a platform to be able to do that. And I think it is really important to share interdisciplinary knowledge and increasing synergy between local communities, indigenous people, organizations, and scientists. And I have a few examples. It is coming from Greenland. We have Bingotsløvik, it's Nature Institute for Greenland, and they're really good at having local communities involved, like in terms of roads of whales, for example. I've been participating for that. And yeah, also fishing. And then we have Elise Mojisafik, it's University of Greenland. I went there, and yeah, they are really opening up onto sustainable nature. And then we have Oceans North. We have actually Jens Ponsen as well from Greenland. Yeah, they are looking into sustaining nature and sea mammals in Greenland. So yeah, this is the point I will say thank you, Bayanak, and I will see you again as well in the afternoon.
Thank you so much, Ole, for these nice words. We have to work with the local communities and for the local communities. At the same time, we see a lot of pressure on these local communities because more and more scientists, especially from social and human sciences, come and solicit you. And we heard, I had a workshop, I think it was last week, confirmed, Samuel, where we were told that there is kind of over-solicitation now. So we have to think about how to best practice with local communities as well. With that, I would like to give the floor to Sherpa Tenzing from the Himalayas, who will give us this indigenous community perspective from the high mountains. Thank you very much.
Okay, before that I'll give some introduction. My name is Tenzing Chogyal Sherpa. So I'm Ole's far cousin from the other side of the world. So he's from the high latitudes. I'll take you to the high altitudes now. So I come from the Sherpa community. I was born in the foothills of Mount Everest from a village called Namche Bazar, which lies more than 3,500 meters above sea level. So until the slides come, I think I'll just go into introductions. Anyways, I grew up with those mountains and grew up playing with those in the foothills of those mountains. So now I'll go to my presentation. I currently work as a cryosphere analyst at the International Center for Integrated Mountain Development. I'll not talk more because the longer I talk, your lunch gets cold, so I'll go much faster as I can. So I'll be talking about the state and fate of cryosphere in the Hindu Kush Himalayas. The Hindu Kush Himalayas, everybody knows, it's one of the largest constellation of mountain ranges. It has all of the 14 peaks in the world and about 240 million people, and 1/4 of the population lives here. So the stakes are much, much higher in this region. And there are more than 50,000 glaciers in this region, which is also why it is also known as the third pole of the world or the water tower of the world. Okay. So I'll just start with this. These are 3 projections from glacial loss projection from 3 reputed studies in different journals showing projections for the Everest region. So all of these show different projections, and the projections range from 8 to 99%. So this large uncertainty means that we basically don't know anything about these glaciers. Now why that is because in the Hindu Kush Himalayan region, these glaciers lie in a more remote region and the accessibility is very difficult. If you take a look at this graph, especially that red solid line, that is all of the weather stations in high mountain Asia. And the red dotted line that you see is all of the glaciers in high mountain Asia. So where we have the maximum area of glaciers is where we have near zero observations or literally none observations. And at the same time, the Hindu Kush Himalayan assessment from ICIMOD provided further evidences of elevation dependent warming, meaning that where these glaciers are located at these higher elevations, that they are even more vulnerable to the changing climate. Now what do we do? So to further elucidate on the fact on why these in-situ observation and field observations are necessary, I was part of a 2018 expedition to Khumbu Glacier. Khumbu Glacier is the glacier that originates from Mount Everest itself. So we went to the ice and we drilled 150 meters, put some temperature sensors in it, and then came after a year to look at how cold the ice is. But to our surprise, the ice was actually warmer than the mean annual air temperature. So that was very surprising to us that the glacier in the highest region of the world is warming up and is warmer than the air. So what this means that, but take in mind that it's all below 0 degrees Celsius. And after 0 degrees Celsius is when it starts to melt. And then these glaciers are slowly going to this tipping point where we can have drastic melt. So is this the same for all of the Hindu Kush Himalayas? That is only 1 point data. So we have 2 reports from ICIMOD in 2019 and 2023, which has a comprehensive analysis of what's happening in the Hindu Kush Himalaya, what is the state and fate of the water, ice, and the society in the Hindu Kush Himalayan. Please read further, but most of the reports and most of the results I'll be presenting will be from these 2 reports. So these are all of the field-based observations in the Hindu Kush Himalayas. There are more than 50,000 glaciers in this region, but we only have 28 glaciers that have been consistently monitored. So that's not even 1%. I think there's 0.05% or somewhere. And most of it is concentrated in the central Himalayas. I think this is also like a glacier, very slow. So if you go towards the Himalayas, you can see most of the in-situ sites where we have long-term, continuous, and high-quality data, which is very important for, especially in case of glaciers, because glaciers are very good proxy to climate change, but for that we need long-term data. A very good example is this plot. If you take a look at this line plot, these are annual cumulative mass balance data from 3 glaciers which are in the Everest region. For the first 3 years, you can see that these 3 glaciers have somewhat different annual mass balances, but when you go to a longer term, the story changes and the picture is quite drastic. So which is why we need these long-term field-based measurements which give a better picture and a better analysis of what's actually going on with these glaciers. So which is why these are all of the field-based monitored glaciers in the region, with Chota Sigri in India being the largest of more than 20 years. And the 2 glaciers that you see, Rikasamba Glacier and Yala Glacier, are the glaciers that we at ICIMOD have been monitoring since 2011. Now it's been more than 10 years that we've been monitoring at an annual basis. And all of the data from these glaciers show a clearly negative trend. It's not very good news for all of these glaciers. So the other thing is that to save 5 meters or to save 10 meters of melt is different thing, but to actually see it in the field is something different. So these are stakes that we put in the glacier. It's a very conventional method, a very old glaciological method. So this... So we visited, this was the stake we installed in 2017, and we visited in 2018. So the stake has melted out, but to give a scale of it on how much that melt is, so that's quite a lot. That gives you into perspective of what 4 meters of ice melt means. And now imagine this all over the glacier. Imagine this going in the Hindu Kush Himalayas. So this just gives a perspective on, we say these numbers, but what does these numbers mean? To actually visualize and to see it in person makes a lot of difference. And you actually understand the scale and gravity of what's actually going on. Now, it's impossible to measure all of these glaciers one by one, so we have these advances in remote sensing and we have sophisticated models, but at the same time, all of these should be in a feedback loop that each should be calibrated and validated and limited, because all of the empirical relations or the physical relations we have should be checked with in situ measurements. Oh, thank you. So through remote sensing, now we can get an idea of what's actually going in a larger scale. And in the case of the Hindu Kush Himalayan region, since the 1950s, there's only been reduction. And that's also quite concerning when you go further down. So everybody knows about the Karakoram. Recently, there's been glacier surges, glacier advances, and even reports of positive mass balances in this region. But now, since the report in 2023, it has also reported that the Karakoram anomaly itself has also ended. Now, the observations from this decade, from 2010, also indicated that the glaciers in Karakoram are also in a glacier wastage. Now, if you look at a larger scale on the glacier mass balance, it also doesn't look good for the high mountain Asia glaciers. When you come to the later decades, by 65% in comparison to the previous decades. Same for the snow. In case of snow, the snow cover is also decreasing, and at the same time, we've had 5 days per decade in average decrease of snowy days, which would be about half a day decrease in snow per year. Now, WMO recently came up, so it was in the Paris Agreement where it was a breakthrough to limit it in 1.5 degree scenario, but the recent report from WMO suggests that there is a 50-50 chance that we might temporarily shift or reach or cross this 1.5 degree scenario. So what does this mean for the Hindu Kush Himalayas? Because due to elevation-dependent warming, 1.5 degrees is already too hot. And even if we are in a 1.5 degree scenario, the glaciers in the HKH might lose 30 to 50% of their volume by 2100, and which would be much, much worse in a 3 degrees Celsius world. So the fact is that every increment of warming matters, and I think this has been reiterated in previous presentations as well. So I'd just like to send this message here. What does this mean, and what does these melting glaciers and how will they impact the downstream community? So we might have 2 phases. One would be the too much water and too little water. These might happen simultaneously as well. We have the formation of glacial lakes, which are the most prominent hazard in the Hindu Kush Himalaya. There have been many clogs, and at the longer time scale, we might have the depletion of water resources due to the depletion of these cryospheric resources. Now, to further highlight on glacial lake outburst floods, if we take a look at this map, you take a look at the highlighted green map. That's most of the population in high mountain Asia. And in fact, 62% of all the population who's affected by glacial lake outburst floods or who's at risk of glacial lake outburst floods is in the high mountain Asia. And about 1 million people live just within 1 kilometer of a glacial lake, which might be at a risk. And we've had recent glacial lake outburst floods in 2019 in Nepal, 2022 in Hunza, 2022 in Uttarakhand, 2023, that was the most recent one in Sikkim. So all of these have had a lot of human infrastructure damages. And if you take a look at past records, this has been going on quite a lot. We've had more than 682 glacial lake outburst floods just in high mountain Asia. And recent reports say that this can increase by 3-fold with the melting glaciers. These hazards can increase more, making it more and more risky for the people that live downstream. So the key message is that there has been significant increase in the glacier mass loss by around 65%. And in a 1.5 to 2 degrees Celsius world, we might lose 30 to 50% of the glacier. And the GLOF risk will keep increasing, and it might increase more than 3-fold in the coming century. And snow cover also doesn't look very good, as it shows a clearly negative trend. Because at the end of the day, as researchers, as policymakers, or any government official, our work should be towards saving the lives and livelihood of the people that live in the foothills of these mountains. Thank you very much.